Alright, so in today's video, I'll be showing you how to create this form. This is a pavilion that we start by creating the base geometry, then creating the pattern subdivision. But the trick on this one was to create a curve attractor. The curve attractor is going to make sure that you can change the pattern size depending on where the curve attractor is. And so I'll be going over all of the steps here in detail. If you're fairly new to Grasshopper and you want to learn more tricks, I'm sure this one is going to be perfect for you. And so if you have any questions, you can let me know in the comments below. I'll have this available on my website so you can see how things plug in. And if you get lost somewhere, you can always reference that. So with that being said, thank you very much for being here. Hopefully you're excited to learn a little bit more, and let's jump right into it. All right, so the first component we'll bring in is going to be a YZ plane. And this is going to be the reference plane where we'll be creating our base geometry, which is an arc. Now, the reason why we use this plane is because typically this arc is going to be by default on the world XY plane. So we want to plug in this YZ plane to be able to create it relative to that plane, and now we can change the size using a slider. Now I want the maximum to be about 400, so let's go to 0 less than 200 less than, let's just go to 400 here. Next, we're going to be creating a copy of this. So for that, we'll create a move component and then use the motion in the X direction. So let's go here to an X unit X, and then we'll use a slider here. We'll just type in 500 to move this arc in the X direction. And so both of these are dependent on this slider. So when you change one of them, both of them are going to change. And next we need to create another arc that is in the middle of these two. So to do this, we'll go to a move component, and we'll be moving this YZ plane to the middle, which is going to be using this unit X, and we'll go to divide by 2. What this does is give us a division. We have A as an empty parameter, which means we can plug in the vector. And then here is going to be 2, which means we'll be in the middle. And we can use this as the motion because we can always divide a vector in half. So now that we have this plane in the middle. And since it's relative to this X movement, it will always be in the middle because no matter what number this is, it will be divided by 2, and that will move that plane to the exact center. So with this, now we can change the size of this one, and we'll be creating another arc. So we'll take this, copy it over relative to this plane. So we'll override this plane, and now we have this middle one that changes size. So the reason why we want to do this is when we loft it, we'll have the form change from a cylinder, because if we have 3 copies of the same size, it'll create a cylinder. But if we have the first one, then the middle one, and then the last one, now we'll have the ability to change the size of this. So let's move this back a little bit, and let's decrease the size a little bit of this one. So now with this, we have the base form and the base geometry. And now the next step is going to be to subdivide this form. Now there are different ways that we can subdivide this, but I like to use the Lunchbox plugin. It has a lot of different panel subdivisions that we could use. And for this particular one, we'll be using the triangle panels. We'll use this loft as the surface. Now we can hide the base surface here, and we have now subdivided this form. So if you want to subdivide it further, we can change the U and V divisions. So let's go here to a new slider. We'll go 3 less than 5 less than 20. And then we can create 2 of them, one for the U division and one for the V. We can also hide now these line segments. And with this, now we can get started in extracting the wireframe from this. Now, what's interesting is that when you take these panels and you bake it, you'll see that, let's see, middle click and then bake. Notice that these are separate panels. So I'm going to take this and actually move it to the side so I can show you what I mean. So these are separate individual panels. And what happens is, let's say if we take these two, we're going to have one line segment that belongs to this surface and one line segment that belongs to this one. So we'll have 2 line segments that overlap. And to fix this issue, we can take all those panels and join them using brep join. And now when you bake this, this is one solid or one continuous joined brep with all of these different panels. And now these are just one relative to those 2 planes. And the reason why we want to do this is because now that we have this, I'm going to hide the triangle panels and just have this one being previewed. And now we can use brep edges to extract the naked curves and the interior curves. The naked curves are going to be the ones on the outside. The interior ones will be on the inside. And now we can use a pipe component using the curves from the naked curves out here. And then we'll just go to a slider to pick the size for the outer frame. I do like to use caps round, so it kind of creates a continuous design here. Let's go here to 3. And then for the pipe, for the interior ones, we'll copy this and just override the interior curves with the curve input here. Now notice they're the same size. That's because we still have not changed the slider for this one. But now we have the outer frame as a different size to the inside one, and that kind of creates a little bit of a stronger base for the design. Next, we're going to be creating the frames. So what we need to do is go back so we can hide all of this and go back to our panels here. Now, when we look at these panels, we have a set of surfaces. So what we want to do is use the edge curves and offset them to the inside. So what we need to do is offset curve. And although these are surfaces, we still can plug these in to the offset curve, and it will use the boundary curve as the curve to offset. By default, it's going to offset to the outside. So we want to now bring in a negative component and offset it to the inside. So let's go here to 2.5. So we've offset this to the inside. Now we're going to just copy this one and unplug the distance and set this number to 0. This way we're just working with the same components, and then this one we can hide. And since things are organized correctly here, all we need to do is use a boundary surface And also, since we're using triangles, the triangle is going to be a plane. So these two can be plugged in. Notice that these are grafted sets, which means that it will do these two individually, then those two individually, creating the entire frame. And now we've kind of created these perforations and these openings with this frame. We can also, when we offset this to the inside, the corners are, we can do sharp, we can do round, we can do smooth, or we can do chamfer. So let's change this to round, or 2. And notice now that we can change the size here. So let's go here to, well, maybe instead of doing it that way, we could just use a fillet so we can have more control here. And then the radius, so notice that now if we override this wire with this one, we can get it working. Now, instead of unplugging it and plugging it back in, a trick that is useful, in this particular case, we double click on the wire and create a relay. And now we can plug this into this one and not necessarily mess with the order that things were plugged in from the beginning. Now, this one, it's not too necessary, but I just want to show you a few tricks that may be useful in another design. So let's hide this one. And now we can hide those two. All right, so in this next step, what we're going to do is have the ability to change the frame size depending on a curve attractor. So let me show you that part, which is going to make it so the pattern is not just this consistent offset being the same everywhere, but it can change when you, let's say, get closer or further away from a curve. All right, so for this portion, we need to first hide all of this and then bring it back to our loft. Also, let's remember that for the middle arc, we do have this plane, and this plane is going to be useful because now we can create a circle relative to this plane. So we'll use this plane as an input, and then the radius just has to be bigger than the largest arc. So let's say this arc is 280 and this one is 193. Well, let's just make this one 300. The reason why we're doing this is because we're going to use this circle. We're going to turn it into a surface using boundary surfaces. And now we're going to be moving this both in the positive X and negative X. So let's move this in the X direction. And we know that for this slider, we have 689. So let's do this. Minus 1,000 less than 1,000 or less than 0 less than 1,000. What this will do is a slider that starts at negative 1,000, it's set at 0, and it has a limit of 1,000. So now we can put this here so that it's not going to move because we have it at 0. So we can hide this, but we can always move this back and forth. Now, here's a trick that you're going to find useful. When you right click on the slider, if we go to edit snapping, we can just go here to 0 and it will give you this snap or this little circle that'll make it really easy to snap to the exact center. So this is useful because sometimes with the slider, it kind of gets tricky to pick, especially when you have a large range, to pick a specific number, but you can set those snapping numbers, and it makes it a lot easier. So now with this, we're going to figure out where the surface of the form and the surface of this circle intersect. So let's go here at the top. You're going to see a tab called intersect, and there's going to be a component called brep and brep. So this is going to evaluate where this one and where this one intersect. And so no matter where you move these, you're going to get a line segment that is intersecting where those two intersect, right? So that line segment is useful because now we're going to use that curve as our curve attractor. So for the next step, we do need to now hide this and bring back the pattern. Now, for these panels, we have the exact, so we can even use these. We want to get the midpoint of all of these because then we need to evaluate how far this curve is from all those points. So it's, if we bring in an area component and we get the center point of all of those triangles, let's bring this up here. Maybe slide some of this over here. Now we can figure out how far these are using curve closest point. So what we need to plug in is going to be the points or the centroids into the point input. Now we do need to flatten the inputs here. And then the curve is going to be this line segment. So now what we need to look at are the distances. So we have 187 different distances that vary. So they're going to, as they get further apart, it's going to be a larger number. As they get closer, they are smaller. So with these distances, now we need to figure out how we can pick the minimum and maximum. So for that, we do the process of remapping numbers. So the numbers are too large here, so we want them to be a little bit smaller. And for that, we need to plug in the distance into the values. The source is going to be using bounds, which means it's going to tell it what's the biggest and what's the smallest number. So the smallest number is 10 and the biggest number is 332. That's the source. And now we're going to change it so it's not such a big range between 10 and 332. We want to be able to pick a specific number. For that, we use construct, I almost forgot that, construct domain, which lets you pick that big and small number. So let's go here to 5.000. And the trick on this is that you need to have a different number for the start and for the end. So let's make this one smaller and this one larger. So the variance between these two is going to be the target, which means that now if we look at the map numbers, now if we look at the domain, we have the smallest number being 1.31, which is this one, and the largest number is going to be 4.447, which is this one. And that's different than this one because we've remapped them to be between that range. So now we can go to this offset, and now we're going to change the distance here. So what we need to do now is, although the output for the map numbers is all the way back here kind of in front of it, we need to now override it with this offset because now the offset's not going to be consistent. It'll be the different numbers that we remapped. So now let's go back here and override the offset curves with the remap numbers. So let's then scoot this back a little bit, make it a little bit easier. We're going to notice that this wire is going all the way back here. Let's just wire display, hide it. Same with this one. Because we know where those are coming from when you select it, but it won't make it messy, and it's nice to keep things organized here. Okay, so we don't see any of the change. Why? Because we have not previewed this offset. Notice that as you get closer to the curve, we have a smaller offset. When we get further away, we have a larger offset. So let's hide both of these, and let's actually bring back this surface. And let's also bring back the pipes. And let's hide these centroids. So notice now that as we get closer to this line segment, they're getting smaller, and we can change that. We can make it larger and then smaller as you get further away, or larger offset as you get further away from the curve. We don't want to exceed the size of this, so maybe 10, let's go to 20 for the maximum, and increase this little by little until we get close to that. And then here, the minimum, that's going to be the smallest one, can also change. So now, as you can see, we have the variable size of the pattern. And what's great about this is that we can change where that is. So we'll keep this at 0, or the middle. The other thing is we can also change it so it's a, let's go change this maximum to 20. We can also do the opposite. To where it gets further away from the curve, there's a smaller offset, and when you get closer to the center, you have a larger offset. Let's go back to that location. This is at 0. But here we have 11. Let's make it 12. So it's exactly in the center here. And then maybe decrease this a little bit. It also depends on the size of your pattern. The denser the pattern, you're going to have to offset it less. So that's another thing to keep in mind here. So now I'm going to increase the size of the pipes. This one will make them 3. And this one for the outside will make them 5. And now let's add a little bit of color so we can see what's going on here. Now the pattern and the panels are in between the inside and the outside. Now when you're trying to develop this, you would either pick the inside to put the panels or the outside. And the way to do that would be to take this loft and offset it to the outside relative to the size of the pipe. So if this pipe is 3 radius, we would offset this loft to the outside by 3. And that way the panels can sit on the outside, and then you can connect them to the structure. For now, we're going to leave it like this. I just want to share with you the process of being able to create a dynamic pattern like this. So let's go here to custom preview. Plug in the outside using a color swatch. I'll hide the wire display on this one as well. and then also plug in this one. So holding down Shift. I'll actually decrease this a little bit. Now let's create another custom preview and then use these panels and then change it. Let's go back and change the pattern size here. So let's make this as large as we can without messing up these little smaller panels here. Notice that when you go too far, even though these are closed, this is the issue that you're going to have. Although I actually think that even though when you go too far, this says that there are some that failed, you still create a surface there. So even though it fails to work correctly in terms of like all of them computing correctly, they will still work. I'm going to increase the angle view. So right now it's at 50. Let's go to 35. All right. So I think that's looking good. The other thing we can do is increase the fillet here. And what happens when you increase it to a point here, they will become circles because they will kind of create a fillet all the way around. We don't want to go too far. And then the minimum is the smallest number, which is right now at 4. Let's just go to 8 here. Or 6. Okay. That is looking good. Now, here's another thing that I want to show you, because right now, basically the design is done, but in terms of using the curve as a curve input for the closest points, we can also use an extend. So here's the thing. When you have a design done, you can always interject anywhere between these wires to create more modifications. Now, a modification that I would see here is, why not take this curve and use an extend curve, use the curve as the curve input, and then extend it, but do the opposite of extending, so shortening it by using a negative. And now we'll use a slider here, let's say 200. So notice that now, if we go to this one, notice that now we can kind of shorten it. So this is by default the same. So if you have 0, it's the same. And if you have, let's make it 200 max. And then if you have 200, it becomes shorter. And therefore, it alters the points that are closest to it. So I'll take this curve, I'll disable this, and then use this curve as the curve input. Now notice that the design is going to change in terms of these now working, but we can also adjust it to either go further down or not. So I want to bring it down far enough to where those get closed off. Or we can even go up here and then just use even a smaller number for the offset here. So those are the things that you can always modify, is things like the closest point or the curve that creates the curve closest points. Now I'll hide this. I'll hide this. And now let's take this and do a render to see what this would look like. So what I like to do is these two are the outputs and they're both plugged into this one. So one thing I can do is double click here to create a relay and then use a geometry component. So you can know that this is going to be the output, and I like to group it. I have it by default as screen. And now we can hide this because this is now the geometry that we could bake. And we'll do the exact same thing with this one. Double click here, bring the relay over, copy the geometry component, override it with this one. So this is now going to be the panels. I'll group this one. And so now we have the script basically organized and ready. All right, so what I'm doing now is taking the output from the custom previews, and I like to use these to bake the output. This way we can keep the materials and we can have things organized. Now, once you have this already baked, we can move this to the side. And if you preview it as a render, you'll see that you'll maintain the materials. Now let's hide the script. And let's focus here with the model here. So now what I'll do is I'll find a view that kind of shows the display of the change of the pattern. So I think this is a good location. And what I like to do is go to perspective, right click, capture to file. And you can do transparent background or not. It doesn't really matter. What's important is that you pick a view that you like and that your resolution is fairly large. This way you can make sure that when we render it, it captures everything correctly. So let's go to OK. And now let's go here and create a capture folder, and we'll capture this as capture 1. And if you want to pick a different location or a different view, we can always do so. So let's go here. Maybe from the inside or something like this. Capture to file. Okay. And then I like to click on it so we don't have to rewrite everything. Just change it to 2. So now let's take this and go to ReRenderai and use that to visualize what this pavilion would look like. And so when you go to ReRenderai, you're going to see this page, and we'll go to render here. Now I've shown before how to render using V-Ray, and that's a really useful tool, but it does take a long time to render as compared to using something like ReRenderai, which helps you be able to visualize it with materials, and it's a fairly quick process, and it's very useful to visualize everything. So let's go back to our capture. I'll drag and drop. Now for the style, there are different, actually you don't need to pick anything. You could just go here to render and see what happens. But you can be a little bit more precise by going to the first one, which are the options. Let's go here to commercial, public. Let's go to a school. Let's go to high tech. Time of the day, I'll go to midday. Season, I'll go to summer. Sky, clear sky. The landscape, I'll go to cityscape. And then materials, let's just use steel. So depending on what prompt you want to use, you can kind of get creative here. They give you an example, modern living room with large windows and neutral tones. We could just call this a modern pavilion with steel frame and colorful panels at a school playground. Just to visualize what that would look like here. Now there are different ways you can do it. Precise, balanced, and creative. Precise is going to be a little bit closer to your design. Although balanced also keeps things very close to your design. It just is kind of has a little bit more freedom. And then here, when you go to creative, it has even more freedom. And sometimes it veers from your design. So I try to stay within the precise and balanced. So let's take a look at what this gives us. All right, so this was it before. And after doing the render, it took a few minutes. This is the result that it gives you. So it maintains the design being the same, and it sets it in a place like a playground, and it gives it the clear sky, the city background. So this is useful because, like I said, it only takes a few minutes. It helps visualize what you're trying to use this for. And now we can upscale this because the generated image, it's a little bit small. So you can always go to upscale. It will give you a larger image, and then you can use that and place it into your folders, and then do a few different iterations to see if you get a better result. Like I said, the benefit of using this is not necessarily for it to do all the work for you, but what it helps you do is visualize your design in a shorter amount of time, letting you make better decisions. And also, if you have clients, you can share it with them, and this helps them visualize, because as designers, we are really good at visualizing things and creating things and coming up with ideas, but sometimes sharing that with other people is a little bit trickier. So I'll go here to download, and I'll place that into my folder, and then I'll keep trying a few different iterations and show you at the end what I got. All right, so here at the end, let me show you the different results that we got. So this is more of a botanical garden, and this is a pavilion where you have people coming in and out. There's, a background, there's the sky. So this is looking pretty good. Then there's this one, which I really like. It's this pavilion that even has some circulation on the outside, but it kind of displays on what it would look like in a large park. And then this one, it's a little bit more within a kind of grassy area. And so those are the different results. I feel like they're looking pretty good. And if you want to use this tool yourself, you can always check out the description and use the code. You can use it for free as a trial, and you can also get a discount for using the tool. So thank you very much for being here. Hopefully you learned a little bit more about other ways of rendering your designs, and I hope to see you in the next one.